Our hats and helmets are engineered for one very specific globular skull shape. Put a modern bicycle helmet on a Neanderthal, and without a vertical forehead to grip, it slides right off. If our ancestors had gone extinct 300,000 years ago, the planet would be shared by three distinct, highly intelligent human species, each tailored to its own ecological niche. The world map would look different. Neanderthals dominating the freezing forests of Europe and Western Asia, Denisovans in the East and the Americas, and the tiny Florasians navigating the archipelagos of Southeast Asia. Because these hominins had long, low brain cases, massive brow ridges, and receding chins, they couldn't use our tools or wear our clothing. Their technologies were engineered by their unique skulls and the extreme environments they called home, starting with the clothes on their heads. Neanderthals thrived in the freezing forests of Ice Age Europe. Each individual required up to 5,000 calories a day, making them high-maintenance ambush predators. Surviving low-light winters meant their brains dedicated massive space to visual processing. This left less room for the social brain, capping their maximum natural group size at around 120 individuals, 30 less than our own. This social cap pushed them toward independent guild states, where they replaced innate social trust with formal physical contracts and strict accounting to manage intergroup trade. Look at the Neanderthal skull profile on the left. Their heavy gear relied on the occipital bun, a bony protrusion at the back of the skull. Their cowls featured an engineered pocket that hooked underneath this bun to anchor a heavy, sun-blocking visor. To waterproof these leathers, they pioneered the first known industrial chemical process, the distillation of birch bark into synthetic pitch. Neanderthal material signs prioritized durability and individual utility, reflecting a society built on small, high-density kin groups rather than anonymous empires. To the east, the Denisovans faced the thin-air peaks of the Himalayas and the sweeping Asian steppes. They possessed the EPAS1 gene variant, which suppresses the overproduction of red blood cells under hypoxic stress. This prevents their blood from thickening in high-altitude environments, allowing them to establish permanent settlements above 4,000 meters. The center Denisovan skull shows an inward mastoid grip. Instead of a chin strap slipping on receding jawbones, headwear clamped behind massive ear bones to secure wide-brimmed shields. These brims blocked intense UV radiation, while bone visors prevented snowblindness. Their genetic resistance to hypoxia and pathogens allowed them to form large, cohesive networks of populations spanning the harshest altitudes on Earth. Far to the south, the tropical archipelagos of Southeast Asia were the domain of Homo floresiensis. Though only 3.5 feet tall, with grapefruit-sized brains, their prefrontal cortices were highly reorganized for executive function and forward planning. The rightmost Floresian skull shows a submandibular web. Lacking a chin, woven plant netting wrapped around the lower jaw to secure their gear. An internal harness on the brow ridge suspended a canopy above the scalp, dissipating jungle heat. Defending against massive predators required extreme coordination. This birthed an egalitarian social structure where survival relied on the reciprocal exchange of resources. Their caloric efficiency allowed for dense populations on limited island resources, fueling the expansion of maritime networks across the Pacific. Distinct cranial structures and environments dictated 3 different ways of life: independent guild states, cohesive high-altitude networks, and cooperative maritime explorers. Our own species functions as an aggressive generalist, prioritizing rapid disruption and standardized innovation. Instead, this alternate world followed a trajectory of deep biological specialization, where technology was explicitly built for intergenerational durability. Civilization is an evolutionary functional attractor. It doesn't require a globular skull to emerge, only a successful response to the variety of the natural world.